Last time we read the spec and pulled out the vocabulary: customer, product, order, line item, quantity, status. Now we turn that list of words into a model. And the goal of a good model isn't just to represent the domain. It's to make the wrong states impossible to even write down. A quantity that's always between 1 and 999. An order that can't skip from draft straight to shipped. If the type system won't let you build a bad value, you delete an entire category of bugs before you run anything. Let's model. Every noun you extracted is one of three things. An aggregate has an identity and is saved and loaded as one unit, and it's responsible for its own rules: customer, product, order. A value object has no identity at all. It's defined entirely by its values. It's immutable, and two of them with the same contents are equal: a SKU, a money amount, a shipping address, a quantity. And an entity has an identity but doesn't stand alone. It lives inside an aggregate. A line item has its own ID, but it only exists as part of an order. You never load a line item by itself. Getting these buckets right is most of the modeling work. The aggregates become your consistency boundaries, the units you lock, save, and reason about. Now, why bother wrapping a number in a type? Because the alternative, passing raw ints and strings and decimals around, is what's called primitive obsession, and it forces you to revalidate the same rule at every single call site and hope you never forget one. A value object flips that. It validates once at the moment of construction, and if the values are invalid, the object is never created. You get an error instead. After that, the type itself is the guarantee. A quantity is between 1 and 999, always, everywhere it appears, in a command, on a line item, in the database. You stop writing if quantity is out of range, because a quantity that's out of range does not exist. The last big modeling move is the order's lifecycle. The spec lists status words: draft, submitted, approved, shipped, delivered, plus canceled, and the temptation is to store that as a plain label and scatter if status equals checks everywhere. Don't. Those words are a state machine. Each state defines which moves are legal. A draft can be submitted or canceled. A shipped order can be delivered, but it can't go back to draft. When you model the lifecycle as a machine with explicit legal transitions, then approve an order that's still a draft doesn't need a handwritten check. It simply isn't a permitted move, and the attempt fails by construction. One place defines the rules. Every caller inherits them. Here's the vocabulary as real types. Order status is deliberately not a C# enum. It's a class, so it can carry validation, its own JSON and database conversion, and behavior. Each status is a named value. And quantity is a whole type whose only job is to be a number between 1 and 999. That single range attribute is the entire rule, and it now holds for every quantity in the system. Look at how little there is here. The constraints from the spec have moved out of scattered checks and into the type definitions, where the compiler and the framework enforce them for free. And here's the order aggregate holding that state machine. Submit doesn't just set a field. It fires the submit trigger, and that returns a result. Either the transition was legal and you get the order back, now submitted, or it wasn't, and you get an invariant violation error, which the API turns into a 422. No exception, no corrupt state. The configuration at the bottom is the single source of truth for the lifecycle. Draft permits submit, submitted permits approve, and so on. Try to approve a draft, and there's no permit for it. So the fire fails. You never wrote that check, the machine did. On success, the order records the timestamp and raises a domain event, which, 4 episodes from now, becomes the message that leaves the service. The model is the rules. So that's the model. Sort every noun into an aggregate, a value object, or an entity. Push each rule into a type so illegal values can't be built, and model the lifecycle as a state machine so illegal moves can't fire. We've barely written logic, and the domain already can't hold an invalid value. Next episode, we make it do things the right side, with commands that are valid by construction, and the 2 hard realities every real service faces. 2 users editing the same order at once, and the same request arriving twice. Subscribe, and I'll see you in episode 3.